Okay, class, now we want to talk about how to find a basis for a column space for this matrix. Recall this is the same matrix we had in the previous example, except we were trying to find the basis for the null space. Now we want to try to find a basis for the column space of this matrix. Recall what's a column space. The column space is all possible linear combinations of the columns of B. So as you can see, it's B1, B2, B3, B4, B5. We listed over here. So all possible linear combination of those. Well, by observations, right? B1, B2, and B5 are pivot column. So one column cannot be expressed by any linear combinations of others column of the other two. Obviously, you can see if there's a 1 here, doesn't matter what number, like B5, you look at B5, you have the 1 right here at this pivot positions. Doesn't matter how many number you multiply by B1, B2, you can never attempt to 1. So it's not possible. All right. So they are independent. So B1, B2, and B5 are independent of each other. So however, here, right, B3 and B4, the ones responsible for the free variable. The free variables x3 and x4 can be expressed as linear combination by B1, B2, and B5. All right. Well, actually, we don't need B5. We can see B3 equals to, let's see, B3 right here equal to 3B1, negative 3B1 plus 2B2. Negative 3B1 plus 2B2. And B4 can be expressed, let's look here, B4 right here, B4 can be expressed as 5B1 minus B2. Get it. So equal to 5B1 minus B2. Okay, so for any element in the column space, we call it V. How about that? V is in the column space of B, then B is a linear combination of the B1 to B5, right? I'm going to write it this way. Plus C5, B5. Well, since we know B3 can be expressed in terms of B1, B2, B4 can be expressed in terms of B1, B2, we can rewrite this as C1, B1 plus C2, B2, C3. Now, B3 can be expressed in terms of negative 3B1 plus 2B2, and B4 can be expressed as 5B1 minus B2 plus C5, B5. As you can see, any element is in the column space of B, which is a linear combination of all 5 columns, can be expressed as a linear combination only involving B2, B2, B1, B2, and B5. So which is linear combinations? Of B1, B2, and B5 only. So in such case, since B1, B2, and B5 are linearly dependent, okay, we can conclude that, well, since they are linearly independent, any element can be expressed by any element in the subspace column space B can be expressed as a linear combination of the 3 vectors. We can say that this set B1, B2, B5 span the column space of B and is a basis for the column space of B. Okay, so there's a remark here. All right, the pivot column, as you can see, B1, B2, and B3 of B form a basis for the column space of B. In addition to that, you can see B1, B2, B5 is a column space of the matrix. And we look at the null space. Null space came from X3 and X4 because B3 and B4 do not have pivot. So the number of the elements of the basis for the null space, which is 2, these 2 vectors right there, and the number of elements of the null space, of the column space, which is 3, B1, B2, B3, added together is the total number of columns you have, which is 5.